All right, today we are diving into one of the holy grails of cryptography, Fully Homomorphic Encryption, or FHE. And let me tell you, this is a technology that promises to solve a problem at the very heart of the internet. It could literally change everything we think we know about data privacy.
So think about this for a second. This is the fundamental trade-off we make every single day online, isn't it? If we want to get any value out of our data, for medical research, for financial services, even just a simple search, we have to just hand it over. We have to trust that all these companies are going to do the right thing with it. But what if we didn't have to trust them at all? And this slide, wow, it really lays out the massive shift here. On the one hand, you've got the old way. It's all about trust. You send your data over and you just have to hope for the best. But on the other side, with an FHE-powered cloud, you replace trust with math. Your privacy isn't some company policy that can change. It's a cold, hard guarantee baked right into the cryptography. And you, and only you, hold the keys.
So how in the world is that even possible? I mean, it sounds like actual magic, right? But it's not magic. It's just some incredibly clever mathematics. So let's pull back the curtain and see how you can actually run calculations on data that you can't even see.
Okay, so the secret is right there in the name. Homomorphic is just a fancy way of saying that the structure of the math is preserved, even when everything's encrypted. Think of it like this. If you take an encrypted number and add it to another encrypted number, the result you get is the encrypted version of their sum. You can mess with the data all you want without ever knowing what the data actually is.
Let's make this super simple with an example. So you take the numbers 2, 3, and 7, right? And you encrypt them. You send these unreadable encrypted blobs of data to some cloud server. Now the server has no clue what those numbers are, but it can still do the math you asked for. It adds the first 2 encrypted things, multiplies by the third, and then it sends you back one final encrypted blob. You use your private key, you decrypt it, and boom, out pops the right answer, 35. And the server? It learned absolutely nothing. Not the inputs, not the output, nothing. But of course, there's always a catch, right? The early versions of this had a huge problem. Every single time you do a calculation, a tiny little bit of mathematical noise gets added. It's kind of like making a photocopy of a photocopy of a photocopy. Each time the image gets a little fuzzy, a little less clear. Well, with FHE, after just a few calculations, all that noise builds up until the final result is just indecipherable garbage. And the solution to this? Oh man, it's a stroke of pure genius. It's a process called bootstrapping. This is the key that makes the encryption fully homomorphic. Get this. The system takes the noisy, encrypted data, and then it uses an encrypted version of its own key to basically decrypt itself. Without actually decrypting itself, it cleans up all the noise, spits out a fresh, clean, encrypted result, and it's ready for the next calculation. It's literally like being able to run your car through a car wash without ever opening the doors. It's incredible. So, with that noise problem solved, you suddenly unlock these absolutely game-changing possibilities. That classic trade-off we've always had to make, between getting value from our data and keeping it private, it just evaporates.
This quote from Jim Salter over at Ars Technica really nails a huge problem we have today. Think about it. Right now, even if your data is encrypted when it's just sitting on a server, a system administrator with the right access could still potentially peek at it while it's being processed in memory. With FHE, that whole problem just vanishes. If the computer itself never sees the decrypted data, well then neither can the person running the computer.
And that's when things get really wild. Imagine being able to run your secret sauce financial models in the cloud, completely securely. Imagine medical researchers from all over the world collaborating on sensitive patient data without ever once exposing a single person's identity. You could even search someone else's database, and they would have no idea what you searched for or what you found. Or 2 rival companies could figure out which customers they have in common without ever sharing their customer lists. The possibilities are just dizzying.
Okay, but a technology this mind-blowing has to have a downside, doesn't it? And for FHE, yeah, for a long time, the catch has been a really big one.
Which brings us to the big question, right? If this gives us perfect privacy, why isn't it just built into every app and service we use? And the answer, like with so many cool new technologies, really comes down to 2 things: performance and cost.
And this chart, whoa, it really shows you just how steep that price has been. I mean, we're not talking a little bit slower here. To do some of these calculations, you need 15 times more memory and a mind-boggling 45 times the raw compute power. It's just a massive overhead.
And to put that into real-world terms, a calculation that might take 1 second on normal, unencrypted data could take almost a minute using FHE. For decades, that kind of performance hit made FHE this really fascinating idea for academics, but it was basically a non-starter for the real world.
But hold on, that is not where this story ends. Because over the last decade or so, FHE has been making this incredible jump from, a cool idea in a lab to something you can actually use, all thanks to smarter algorithms and just way more powerful computers.
Check out this timeline. The first real workable idea, that was only back in 2009. That's not that long ago. But just 10 years later, you have IBM already running successful tests with major banks on real data. And now, today, there are powerful open-source libraries that anyone can download and start building with, which is just pouring fuel on the fire of innovation.
Let's dig into that IBM trial for a second, because it's a big deal. They worked with a bank, they used a machine learning model on a huge set of real financial data, hundreds of thousands of entries. And here's the kicker. The model was just as accurate working on the encrypted data as it was on the original clear data. It proved that FHE wasn't just a toy anymore, it was ready for prime time.
The tech has gotten so good that the industry is now actually working on standardizing it. And that is a huge step. When you start creating official standards, it's what you need to get this stuff adopted in really sensitive areas like healthcare and finance. That's how you know this is being taken seriously as a fundamental building block for the future.
And all of this leaves us with one last, really exciting thought. That massive performance cost, the one that was once millions to one, is now less than 100 to 1, and it's getting smaller every single year. So as the cost of perfect, mathematically guaranteed privacy gets closer and closer to zero, what are we going to build? What problems that seem impossible today will we finally be able to solve when we're no longer afraid to share our data?